So we have to just go for. So we have just taken L is equal to T minus V, then Lagrange's equation of motion d upon dt del L upon del Qi dot minus del L upon del Qi, that must be equal to 0. And from here we can have also a cyclic coordinate del L upon del Qk, some coordinate Qk is equal to 0, which may be what? Cyclic coordinate. And we have solved some basic problem. Mainly we have solved the problem particle as a simple pendulum, moving pendulum, and double pendulum. This type of problem we have solved. So now let's try to go for one little bit some advanced level problem. So let's try to go for this. So what we have basically one particular rod is there, and there is some mass m, another mass m is there, and this length is a, and here is another mass. Let's say this mass is again have, let's say this mass is m1 and this mass is m2, and this all length is a, and the whole system is rotating about this axis with omega velocity. The whole system is rotating with a z axis about omega velocity. So what will happen? This m2 can move up and down, and such that mass m1 can move just away or towards the z axis. Yes, you can visualize this all thing. When m1 and this m1 will go towards z axis, then m2 will go downward. When m1 will go away, then m2 will go upward. So this is all about the situation. So now we have to just write the Lagrangian of a system. So before writing the Lagrangian of a system, we have to calculate the degree of freedom. So can you able to calculate the degree of freedom? So obviously, which coordinate system will be the best one to define this particular system? किस coordinate system में से लिखना चाहेंगे हम?
Spherical polar.
Obviously, Puneet, आप अभी आंसर नहीं दोगे, है ना?
Okay, sir.
Try to give the and other लोगों को आंसर देने दो, ठीक है? Which coordinate system is the best one? Especially new students, spherical polar coordinate. Okay, so let us try to write the Lagrange's. Just try to write the equation of constraint in a spherical polar coordinate. I can just put this point is 0, 0, and 0. So if this point will free, then in a spherical polar coordinate, I can write it. This is r1, theta 1, phi 1, and this point will be something like r2, theta 2, phi 2, and this point will be r3, theta 3, phi 3. Yes, if this point would free, अगर ये सारे के सारे पॉइंट फ्री होंगे तो यही होगा कहानी. But these points are not free. There are some stories are there. So what is this story? ये distance क्या है? R1, and this distance is always what? Fixed. From origin to this distance is fixed. So my first equation of constraint is R1 is equal to A. What is my second constraint? Second constraint क्या होगा? For the second particle?
R2 is equal to A.
Very good. So that value is equal to what? R2 is equal to A. Now, so these two are constant. Is that R3 is equal to B is equal to some fixed quantity, or it is variable?
Variable.
That is variable. Very good. Now, can I say that this angle is theta 1 and this angle is theta 2? And this theta 1 and theta 2 are variable or fixed value?
Variables.
Variable. Very good. But from the symmetry of problem, hence this distance is same, this distance is same. Can I say theta 1 is equal to what? Theta 2? क्या कह सकते हैं? θ1 इज इक्वल टू θ2 इज इक्वल टू सम थीटा. यस.
Yes, sir, we can say.
Sir,
Sorry?
please explain on what basis you are saying.
What I am saying that this mass m1 and this mass m2 will always make the same angle with z axis. It is correct or false? This mass m1 and this mass m1 will always make the same angle with z axis. Is that this statement is correct or false? बताइए. Correct. Always this will make because this distance is fixed and this distance is fixed. So if this particle will go upward, then this two particle will move with the same amount from this particular distance. So why θ1 is equal to θ2 is equal to theta. Okay. Now let's go for the rotation of this particular thing. So if it is going to rotate, suppose it is going to rotate, then the rotation is in what? XY axis. So there is two type of rotation. One is two type of angular variation. One is about Z axis. This θ1 and θ2 is measured from Z axis, and another is you can rotate about your Z axis. So can I again say that phi1 is equal to phi2 is equal to phi? लिख सकते हैं इसे? phi1 plus phi2, phi1 is equal to phi2 plus some constant, but that constant is irrelevant because when you will go for dot, then this constant will be 0. First order derivative is 0. So I can take this constant is 0. What I am trying to say, suppose this is mass m1 and this is mass m2. Then if this mass will move phi angle, then this mass is also move phi angle. Something like this. Are you people comfortable?
Yes, sir.
Yes. Now, this is for mass m1, first m1 and second m1. Now, let's try to go for this one, for m2. For m2, can I say that θ3 is equal to 0 as well as phi3 is equal to also 0? Are you people comfortable?
Yes.
θ3 is equal to 0 as well as phi3 is equal to 0. Why? Because it is not going to rotate, it has just only translation motion. It has just only translation motion. It will just go along Z axis and it will just try to rotate something like this. Are you people comfortable? Now, there is one more constraint. Is that this R3 is fixed or it will dependent on theta?
Dependent on theta.
Dependent on theta. So what is this R3? R3 is equal to, can I write in form of theta? What will happen? R3 is equal to?
So A cos theta 1. 2A cos theta 1.
Very good. That value is what? 2A cos theta. So I have put it θ1 is equal to θ2 is equal to theta. So R3 is equal to 2A cos theta. So are you people comfortable? Now, how many equation of constraints are there?
7.
7. So what is your, this is your first constraint. This is your second constraint. This is your third constraint. This is your fourth. This is your fifth. This is your sixth. And this is your seventh constraint. So what will be your degree of freedom? Your degree of freedom is 3 into 3 minus 7 is equal to 2. So you have 2 degree of freedom. And let's try to see what are the generalized coordinate, which is just trying to solve this particular equation. Clear here? So let's try to solve the Lagrangian of a system. यहाँ तक clear है ना? Everyone is comfortable?
सर एक बार आरटी वाला पॉइंट बताएंगे प्लीज.
हाँ, देख लीजिए. देखो. This distance is R3. Yes? क्योंकि यही तो ऊपर नीचे हो रहा है.
Yes, sir.
Yes. So this distance is equal to this distance plus this distance.
Yes, sir.
What is, if this distance is a, this angle is θ1, then this distance is a cos theta,
A cos theta.
and again this angle is also theta, then this distance is also a cos theta.
Yes, sir.
So this distance is what? 2a cos theta.
Summation of 2 cos theta.
हाँ,
Okay.
a cos theta plus a cos theta. That is what? 2a
2
cos
cos
theta.
theta.
ठीक है?
Yes, sir.
Okay. So let's try to go for the Lagrangian of a system. So for the first particle, Lagrangian is nothing but what? Kinetic energy minus potential energy. So let us first write the kinetic energy. What is kinetic energy of first particle in a spherical polar coordinate? m1 r dot square or r1 dot square r1 square θ1 dot square plus r1 square sin square θ1 phi1 dot square. This is for first particle. Then we will go for what? Second particle, and that value is half m2 r2 dot square plus r2 square θ2 dot square plus r2 square sin square θ2 sin square θ2 and phi2 dot square. Now for the third particle, plus half m2 r3 dot square plus r3 square θ3 dot square plus r3 square sin square θ3 phi3 dot square. Okay. Now we have to put the
Sir,
equation. हाँ बताइए.
sir, for the second particle also you have written
अच्छा
M1.
अच्छा. M1. Okay, good. So this value is M1. Good. So what will happen? We have to just go for writing the equation of constraint. So what will happen? R1 is equal to A, R2 is equal to A. So what will happen? R1 dot is equal to A, R2 dot is equal to A. Yes, sorry, R1 dot is equal to 0 and R2 dot is equal to 0. Sorry. Okay. Now θ1 dot is equal to θ2 dot is equal to theta dot. होगा ना? θ1 dot is equal to θ2 dot is equal to theta dot. Similarly, we have phi1 dot is equal to phi2 dot. Phi1 dot is equal to phi2 dot is equal to phi dot. And now we have R3 dot. And what is your R3 dot? R3 dot is equal to minus 2a sin theta dot. So what are generalized coordinate here? क्या क्या generalized coordinate होगा? What are generalized coordinate?
Theta dot and phi dot.
Theta and phi. Theta dot and phi
Yes,
dot
yes,
ne theta and phi. Okay.
Yes, sir.
So this is your half m1 and this value is equal to a square theta dot square plus a square sin square theta phi dot square. Same thing happened to this one also, isn't it? Because this mass is m1, so same thing happened to this one. So we have to multiply with 2 into this. Okay. And now let's go for R3. R3, this term is 0. This term is also 0. Only this term is there. So we have that is half m2. And what is R3 dot square? Is equal to 4a square sin square theta dot square. So this is my kinetic energy. And if we are going to write the kinetic energy of a system, then So this value, this kinetic energy is equal to m1 a square theta dot square plus a square sine square theta pi dot square plus 2 m2 a square sine square theta, and this is what? Theta dot square. This is your kinetic energy. Okay, and now let's try to go for potential energy. So what is potential energy for first particle? Just tell me. This is something like this, isn't it?
Yes, sir.
What is potential energy for first particle?
M1 R1 cos theta 1.
Very good. So you have to just go for this distance. है ना? So you have potential energy for first particle is minus m1 r1 cos theta 1 minus m2 or again m1 r1 cos theta 1 and minus m1 and sorry, this is not r1. Just a minute.
R2 cos theta 2, sir.
Just a minute. Wait. So this distance is A. So what is this distance? A cos theta, isn't it? This distance is what? A cos theta. So potential energy is minus m1 g A cos theta for first particle. For second particle, this you have same potential energy. So minus m1 g A cos theta. Theta 1 is equal to theta 2. So this will be same. And last one, you have minus m2 g 2a cos theta. So this is your potential energy of a system. Is that any cyclic coordinate if we are going for writing Lagrangian of a system?
Yes, sir.
What is cyclic coordinate?
Phi.
Phi is your cyclic coordinate. So if phi is your cyclic coordinate, which quantity is going to conserve?
P phi.
So you can have del L upon del phi is equal to 0, which implies del L upon del phi dot is equal to P phi is equal to constant of motion. And what is this constant of motion? The constant of motion is, what is this value? 2 m1 a square sine square theta phi dot. This is your, this term is going to constant of motion, isn't it? And this is nothing but the angular momentum along z axis. ये किस direction में angular momentum होगा? Along z axis. So this is one of the very nice problem which is also given in your tutorials also. So you have to try to solve this particular problem. Okay? Clear
Yes,
है? Okay. Okay, now let's try to go for our next problem. ठीक है? So just try to do this problem with yourself, है ना? और जब होगा तो फिर आप इसे, अगर कोई confusion होता है, if you have any doubt, you can let me know all this particular thing. Okay, let us try to go for our next problem. This is again very interesting one. So this is a vertical circle and whose radius is A. And there is a pendulum attached to this particular circle and the length of pendulum is B. This is also given to in your tutorials. Okay, so you can solve it with yourself, but let us try to solve it. This is very interesting one. So this is in a vertical circle and this point is able to rotate on the on this particular circle. So what you can imagine something like this. You can just imagine that if this is your pendulum, it can just going to rotate on this particular thing. Are you getting my point? So this type of motion is there. So you can have just at some particular point, it can just go like pendulum, but same time its point of position is also going to rotate. So this type of problem always come into your examination. Okay. Okay. So how you will deal with this type of problem? So what will happen? First, we have to calculate the degree of freedom, and this is in XY plane. So where I should put origin? I should put origin at this particular point. Let's say this is my x-axis and this is my y-axis. So this is in a vertical plane, and this is my z is my direction of gravity. Okay. Now, how you will calculate the degree of freedom? Now, in this type of problem, you have to be very much careful that if you are, and this mass is m, you have to very much careful that if you will take that one mass, that n is equal to 1, then it will create a problem. In general, when we are calculating the degree of freedom, what we are doing? जब हम degree of freedom को calculate करते हैं तो क्या करते हैं? We always use 3n minus k, isn't it? And what is n? What is n here?
The number of particles.
Very good. यहाँ पर आप क्या करते हो? Number of particle. But now you have to correct this particular thing. Obviously, it is number of particle in most of the cases. But thing is that here you have to put n is equal to number of points which can be freely moved. So can I assume that this point has mass m is equal to 0 and which is freely moving on a vertical circle?
Yes, sir.
Can we assume this thing? Because this point is also contributing into one particular degree of freedom. हो रहा है ना ऐसा?
सर हम पॉइंट को मास
Sorry? क्या बोल रहे हो?
पॉइंट को हम मास कैसे मतलब
मास इज इक्वल टू 0, m इज इक्वल टू 0 ये कंसीडर किया है, मास नहीं कंसीडर किया है। एक ऐसा पॉइंट कंसीडर किया है जिसका मास 0 है। कर सकते हैं ऐसा एज्यूम? जैसे मैं आपसे एक बात कहता हूं, सिंपल पेंडुलम में ये पॉइंट आपका फिक्स होता है। आर यू गेटिंग माय पॉइंट? दिस पॉइंट इज फिक्स्ड। व्हाट इज मैथमेटिकल मीनिंग ऑफ दैट? आपने एक प्रॉब्लम ये लिया, दूसरे प्रॉब्लम में आपने यहां पर एक मास लिया था जो कि मूविंग पेंडुलम था, रिमेंबर? ऐसा लिया था और दूसरा ऐसा लिया था, और तीसरे में मैं कुछ ऐसा ले रहा हूं रोटेटिंग पेंडुलम में। सो नाउ व्हाट इज मीनिंग ऑफ दैट इफ दिस पॉइंट इज फिक्स्ड? मैथमेटिकली इसका क्या मतलब होगा?
थीटा फिक्स।
थीटा कहां से फिक्स हो गया? कुछ भी मत बोलो। अरे नहीं भाई, ये पॉइंट फिक्स है, इसका मतलब क्या है मैथमेटिकली? व्हाट इज मीनिंग ऑफ दैट?
सब पॉइंट विथ मास 0.
दिस पॉइंट इज मास 0, देन इट इज फिक्स्ड।
Mass infinite.
Mass infinite. You have to assume, suppose something had rigid support. Suppose this has something, suppose this point has rigid support, it is not able to move. That means the mass at this point is actually infinite. Are you getting my point? Because only infinite mass cannot move. If you will give some finite mass, it is 100% try to move into this direction. Are you getting my point?
Yes, sir.
Anna? So hence this point is have mass infinite, so it is not able to move. So this point is not able to contribute into degree of freedom. Are you getting my point? Anna? कि ये पॉइंट डिग्री ऑफ फ्रीडम में कंट्रीब्यूट नहीं करेगा. But when you will give the finite mass, then it will surely contribute the degree of freedom. But in the problem, it is just, you can imagine that this is just fixed with a hook. हुक समझते हो ना, एक पर्टिकुलर हुक से फिक्स किया गया है जिसकी मास इसके कंपैरिजन में बहुत छोटा है. ये ऐसे तो नहीं होगा ना, कोई भी एक रॉड होगा, दैट हैव टू बी, कोई भी रॉड होगा तो कुछ किसी तरह तो इसके अंदर डाले होंगे हम. Yes or no?
Yes,
And its mass is very, very less than this particular mass of this particular M. Same type, this mass is very, very heavy than with the respective mass of M. Here, these two mass are comparable to each other. So both, we are taking the both mass. So can I assume that this mass have zero mass and this, but this will also contributing into degree of freedom? ऐसा assume कर सकते क्या?
yes, sir.
We can assume it. So now, but when we will write the kinetic energy for this particular point, then obviously that will not come into picture because I am assuming that this mass is equal to what? 0. हम ये assume कर रहे हैं कि ये mass क्या है? 0 है. सोच लीजिए. This is logical. Everyone is comfortable? Okay. So now let's try to go for degree of freedom. So suppose I can assume this is some finite mass, but that value of mass is equal to M is equal to 0. So I can put this is X1, Y1, Z1, and this mass is X2, Y2, Z2. And what we are going to do, what are the equation of constraint here? This is moving in XY plane. That means what? Z1 is equal to 0.
Yes, sir.
And this is also moving in XY plane. So that means Z2 is equal to 0. And this point is always fixed with respect to origin. This is my origin. Okay. This is my origin. This point is always fixed with respect to origin. Then what will happen? This distance is always fixed. So x1 minus 0 whole square plus y1 minus 0 whole square is equal to a square. And this distance is always going to fixed, isn't it?
Yes, sir.
Yes. This distance is always going to fix. So what will happen?
x2 minus x1 whole square plus y2 minus
x2 minus x1 whole square plus y2 minus y1 whole square is equal to what? B square. Okay. Can I write this thing? है ना? So what will be degree of freedom? 3 into 2 minus 4 is equal to 2 degree of freedom. Now we can calculate this particular thing. So can I take this angle as my theta1? ले सकते क्या? And I can take this angle is my theta2. Can I write this thing? Okay.
Yes, sir.
So I have to only write the kinetic energy for this because for this mass I have taken M is equal to 0. So there is not any problem. Isn't it? So what is kinetic energy for mass? Kinetic energy is half M x2 dot square plus y2 dot square. x2 dot square plus y2 dot square. And what is my potential energy? The potential energy is equal to, what is this value? Minus m2 g y2. Yes. Are people comfortable?
Yes, sir.
So what I have to do, I have to now include this particular theta1 and theta2 in my calculation. So can I write x2 is equal to x1 plus b sin theta 2 लिख सकते क्या? This distance is x1 and this distance is b sin theta 2, isn't it? And what is x1? And what is x1?
A cos
A cos theta 1.
Very good. So that value is a cos theta 1 plus b sin theta 2. Okay. Now, प्लीज आप में से किसी का अनम्यूट है, आप अपना म्यूट करके रखिए, है ना? There are noise is coming. Okay, good. And now, what is your y2? Y2 is this distance, isn't it? Yes or no? This is your y2 because this is your 0, 0. So this is your y2. So can I write y2 is equal to, this is your y2. Y2 is equal to this distance minus this distance. So this distance is basically, what is this distance? B cos theta 2 minus A sin theta 1. Just look at, I am correct or wrong?
Yes, sir. Correct.
Correct hai na? Okay. Now what you will do, you will just go for calculating x2 dot square and y2 dot square. So when we are going to write the x2 dot, then this value is minus a sin theta 1 dot plus b cos theta 2 dot y2 dot is equal to minus b sin theta 2 dot minus a cos theta 1 dot. Look at, are you people comfortable?
Yes, sir.
Okay. Now let's try to write the final Lagrangian of a system. So what do you have? You have actually, let's say this is A, this is B, this is C, and this is D. Now, the Lagrangian is nothing but kinetic energy minus potential energy. So what will happen? A square plus D square. What is going to happen? A square plus D square. So you can see x2 dot square is A square plus B square minus 2AB, isn't it?
Yes, sir.
So this is something A square plus B square minus 2AB. What is y2 dot square?
A square plus B square plus
C square, y2 dot square, C square plus D square plus
Plus
2CD.
CD.
Okay. Now we will collect A to A. So A square plus D square. What will happen? चलिए बताइए फटाफट.
The A square will be common and sin square plus the cos square will be 1.
A,
So then-
A square theta 1.
Very
dot
good.
square.
A square theta 1 dot square. ठीक है? Now B square plus C square.
B square theta 2 dot square.
Very good. B square theta 2 dot square. Now you have cross term. So 2CD minus 2AB है ना? तो 2CD से क्या बाहर आएगा और 2AB से क्या बाहर आएगा? 2AB theta 1 dot theta 2 dot. Correct है ये?
Yes, sir. There will be one m term, sir. Half m.
Half m will be there. Obviously, half m will be there. Assume m is equal to 1. Okay. Now, which
Okay.
term is going there? You have sin theta 2 cos theta 1 minus sin theta 1 cos theta 2. What is this value? Sin theta 2 minus theta 1. है ना? Very good. So this is my kinetic energy. So just write kinetic energy first. So this will be half m a square theta 1 dot square b square theta 2 dot square plus 2 ab theta 1 dot theta 2 dot, and that value is what? Sin theta 2 minus theta 1. This is your kinetic energy. And what is your potential energy? Your potential energy is minus mg y2. And what is your y2? Is b cos theta 2 minus a sin theta 1. So this is your potential energy of a system. Okay? Everyone is comfortable?
Yes, sir.
Okay. So now you can see which type of system is that. ऐसा problem किया है? कौन सा system था?
The flipping.
सोच कर बताओ. डबल पेंडुलम है ना? डबल पेंडुलम ऐसा ही तो कुछ आता था,
Yes, sir.
है ना? Only we have just one mass is not contributing. So this is something like double pendulum. You can just go and match it. So there is also degree of freedom 2, and here is also degree of freedom 2. The symmetry is exactly same as what? Double pendulum. Okay. So I hope these are the some problem we have to discuss. Now you have to go for previous year questions and you have to solve it. But before going to that, let me give you a final one more concept, and that concept is what? Generalized force. So let's try to give you the final concept. That is what? Generalized force. ठीक है? यहाँ तक clear है ना?
Yes, sir.
Okay.
Yes, sir.
हाँ बताइए.
Sir, in this problem, when the wheel will rotate, then the simple pendulum will continue his work, or it will stop in the middle of the motion.
If you want to rotate the wheel,
Yes, sir.
so that will be another problem. That is entirely different problem. Okay, simple pendulum will be there, but that simple pendulum will behave like a something like a spherical pendulum. Are you getting my point?
Yes, sir, I'm telling about in this problem when the wheel. Yes, sir.
When the wheel will rotate, and that will be the new problem where this simple pendulum will convert it into a spherical pendulum. Are you getting my point?
So there is noise from another side.
From my point, from my side, there is not any noise. Please बंद करो भाई. कौन है ये?
Yes, sir.
Is it comfortable?
Yes, sir.
Yes, sir.
चलो. अब बताओ क्या प्रॉब्लम क्या है?
सर यही प्रॉब्लम में जब वो
एक मिनट पहले प्रॉब्लम अच्छे से कर लेते हैं. यही तो है. अब इसको कैसे रोटेट कराना चाह रहे हो ये बताओ.
इन XY प्लेन.
ऐसे ही रोटेट कराना चाह रहे हो?
Yes, sir.
That it is not a logical unless until you will not give the mass of this particular ring. Okay?
Okay, sir.
If you will give the mass of this particular ring, then what will happen? Then obviously you have to take the moment of inertia and all other thing in your calculation. Okay?
Yes, sir.
है ना? So इसका रोटेशन भी आएगा, तो आप इस डिस्क, इस रिंग का रोटेशन का मोमेंट ऑफ इनर्शिया भी उसके अंदर इंक्लूड करोगे. आर यू गेटिंग माय पॉइंट?
Yes,
ठीक है?
rotational kinetic energy.
Rotational kinetic energy for that thing, and also you have to check what will be the relation of this particular rotational motion to this particular motion. Okay? If we both are independent, then this problem is not any sense. It will not make any sense. Okay? Such that in this year, in the examination, this type of problem has come into your exam. ठीक है?
Yes, sir.
है ना? कि एक डिस्क दिया हुआ था or a spring with a, and I have solved it. You can just go and watch my video. And this is also rotating. This is going downward. So there are this type of questions can be there, but this has some mass and it is rotating. Okay.
Yes, sir.
Okay. But when we will go for rotational dynamics, then we can discuss this type of problem. Okay.
Yes, sir.
Okay. So let me conclude the Lagrangian first, and I will just give you the final discussion all about the generalized force. So what is generalized force? So we have, suppose, what is your force? If you know the potential, the force is defined as what? Minus del V upon del X. Okay. So this is your potential. So this force will be defined when your potential is only and only function of generalized coordinate. Are you getting my point? It may be possible that your potential may function of generalized coordinate as well as generalized velocity. For example, कहां पर होगा ऐसा potential? For example, कहां होगा ऐसा potential? कहां पोटेंशियल इस तरह से मिलेगा जो कि वेलोसिटी के ऊपर भी डिपेंडेंट हो? बताओ पुनीत, इसका आंसर दो।
सर ईएमटी में एनकाउंटर किया था।
ईएमटी में कहां पर? ईएमटी में कहां पर? अब ऐसा आंसर मत दो, डायरेक्ट आप
यस यस।
प्रिसाइज आंसर दो। हवाबाजी से काम नहीं चलेगा, है ना?
नहीं सर, मैं वही रिकॉल करें।
चार्ज पार्टिकल इन इलेक्ट्रोमैग्नेटिक वेव, है ना? इलेक्ट्रोमैग्नेटिक फील्ड, चार्ज पार्टिकल इन इलेक्ट्रोमैग्नेटिक फील्ड. So where you have to this type of potential where that will be function of velocity.
Yes,
Now, so if your potential is actually function of generalized coordinate and generalized velocity, and it may be function of time, then what is my Lagrangian of a system? D upon dt del L upon del Qi dot minus del L upon del Qi must be equal to 0. And when you will write this thing, d upon dt del upon del Qi dot, and what is your L? L is nothing but minus t minus v minus del upon del Qi, and this L is nothing but t minus v must be equal to 0. And what you can write this whole thing? This whole thing you can write in a form of d upon dt del t upon del Qi dot minus del t upon del Qi is equal to d upon dt del v upon del Qi dot, and you can just use this particular thing. I will just take this space, minus del v, and this is del v Qi dot del Qi, and this whole term is identified as generalized force. Okay, if someone will ask you what is generalized force, then you have to, and it will give you potential, then generalized force is equal to d upon dt del v upon del Qi dot minus del v upon del Qi, and this is identified as generalized force when you have potential energy as a function of generalized coordinate and generalized velocity. And similarly, this force can be also written in terms of kinetic energy, that is del t upon del Qi dot minus del t upon del Qi. Okay, so you can write it in form of kinetic energy also. So this is your generalized force, and you can easily check when potential is not explicitly function of generalized velocity, then your force when del v upon del qi dot is equal to 0, which implies fq is equal to minus del v upon del qi. Are you getting my point?
Yes, sir.
So this is your generalized force. In some of the problem, they will give you potential. You have to be very much careful that whether it is function of generalized coordinate or generalized velocity or not. Okay. So this is all about from my side of Lagrangian of a system. So I will go for one more class in which we will solve the previous year questions. But before that, I will suggest you that first go and revise the topic and go for the previous year questions with yourself. And then I will do some basic problem, some more conceptual, little bit tougher problem, little bit interesting problem from the previous year section into next class. Okay. So up to that, next 1 or 2 days, what you have to do? You have to just try and revise each and everything, because in the next week we will just start the Hamiltonian and all other problems. Okay, ठीक है? Hamiltonian, canonical and everything will be finished into next week. Okay.
Yes, sir.
So next week
Yes,
में
sir.
बहुत ही ज्यादा important रहेगा, mainly नेट और गेट वाले स्टूडेंट्स के लिए. ठीक है?
Okay, sir.
Yes, sir.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.